Have you ever opened up your inbox and wondered, how exactly does Gmail know what's a spam message and what's a real actual email from a friend? Or, when you finish a show on Netflix and it just instantly recommends the absolute perfect movie to watch next. Or even when you upload a photo to Instagram and it somehow recognizes your friends' faces right away. We interact with these features every single day, completely taking them for granted. But what is actually going on behind the scenes to make all the whole shebang happen?
Well, the secret behind these everyday tools isn't magic, even though, let's be honest, it sometimes feels like it. The real answer is machine learning, and specifically, a very common, super powerful type of it called supervised learning. So today, we're breaking down the exact mechanics of this invisible technology. We're going to use the core concepts of supervised machine learning to see exactly how these computers learn. Okay, let's dive into this. Here is our roadmap for today's explainer. The magic behind your screen, what is supervised learning, the four-step process, two types of learning, and finally, real-world applications.
Starting with Part 1, the magic behind your screen. Which brings us right into Part 2, what is supervised learning?
Okay, here's the formal definition. Supervised learning is a type of machine learning where a computer learns using labeled data. So the crucial point is that word right there, labeled. The computer isn't just staring at random chaotic information. No, it's looking at data that humans have specifically, carefully labeled with the correct answers. Without those correct answers attached to the data, the computer simply can't learn in this supervised way.
To really wrap your head around this, think of it literally like teaching with flashcards. If you show a toddler a picture and say, cat, and then show another picture and say, dog, you are providing labeled examples. Now, if you do this with a computer, feeding it millions of photos clearly labeled cat or dog, the algorithm eventually picks up on the visual patterns to identify totally new photos entirely on its own. It's basically a giant game of pattern recognition.
Moving on to Part 3, the four-step process.
Let's move to and see how this builds across a standard machine learning pipeline. It usually works in four distinct steps. Step 1 is to collect data. For example, let's say we pull together a massive list of house sizes and their corresponding house prices. Step 2 is where we train the model. This is where the algorithm studies the patterns in that data, connecting the square footage to the dollar signs. Step 3 is to test the model. We essentially hide the answers on some of the data and just check how accurate its predictions are. And finally, Step 4, predict new outcomes. Because it learned the patterns, the machine can now accurately estimate the price of a brand new house it has never even seen before.
Now, I know this sounds incredibly complex, and yeah, it definitely gets complex when you're running it at a massive scale, but it's really worth noting that at its absolute core, this whole pipeline of training and predicting relies on foundational math. Things as simple as that old high school equation, y equals mx plus b. The algorithm is essentially just drawing the best possible mathematical line through all those data points to make its future predictions.
Let's look at Part 4, two types of learning.
Now, what's really interesting about this slide is how the process splits depending on what we actually want to predict. It breaks down into two fundamental types. On the left is classification. This is when the machine predicts distinct categories. For example, looking at an incoming email and deciding, is this spam or not spam? There's no in-between number, it just goes straight into a bucket. On the right, we have regression. This is when the machine predicts continuous numbers, like those house prices we just talked about, or checking your weather app for tomorrow's exact temperature forecast. So it's basically categorizing things versus calculating numbers.
And that brings us to Part 5, real-world applications.
So why does this actually matter to your daily life, your safety, and your digital experience? Well, supervised learning powers essential technologies we interact with or benefit from every single day. For instance, it's the silent guardian of your bank account, constantly analyzing transactions to detect credit card fraud by flagging out-of-character purchases. In hospitals, it supports crucial medical diagnoses by identifying patterns in X-rays or patient data way faster than a human could alone. For entertainment, it dramatically improves those streaming recommendation systems we all love so much. And looking to the physical future, it even assists the incredibly complex sensors and decision-making on self-driving cars, helping them navigate our world safely.
And this brilliantly illustrates our main takeaway today. Supervised learning is all about learning from examples. By taking the time to feed the machine clearly labeled data, these algorithms can turn around, make remarkably accurate predictions, and literally solve immense, real-world problems for us.
But, that leads us to a massive, fascinating question to end on. If supervised learning is what happens when we give the computer all the answers up front with carefully labeled data,
what happens when we don't? What happens when we just give a machine a mountain of raw, completely unlabeled data and basically ask it to figure it out on its own? Well, that is the next major frontier of AI. That is unsupervised learning, but we are going to have to save that for another explainer. Keep learning, keep asking questions, and I'll catch you next time.